So this lesson we're going to go more into detail of the distributive property, and then we're going to talk about algebraic expressions. So using words to write equations, or using equations and writing words. Okay, so if I go to this, some words that might be used are quotient. Okay, quotient means the same thing as dividing. That's a division sign, sorry. Product is the same thing as multiplying. Plus is obviously addition, subtracted from, subtraction, minus is minus. So these are just some different words that we could either write or will be written in an algebraic expression that you're going to have to relay from. Okay, so a number q is doubled plus z tripled. Okay, when it says a number q, it means if I picked any number for q. So if, say, I picked a number q, so say I want 3 to represent q, so then I would put 3 in for q. So it's just a different way of saying q is just some variable that we picked. So we got a number q is doubled, okay? When I want to double something, I want to multiply it by 2 because I'm doubling it. I want it to double in size. I'm not going to square it because, say I square, I don't want to do that one. Squaring works actually, but tripling doesn't, because tripling would be multiplying. So say I want to do 3 times 3 times 3, okay? It's just different. You want to multiply it by it. So you got a number q is doubled. So we're going to want to do, since q is being doubled, it's going to be 2q. And then it's plus z tripled. So we're going to do plus z tripling it. So we're going to have 3 times z because we're going to triple it. Okay? Say I wanted z to represent 2. So then 3 times 2 would be 6. Okay? The reason that we're not cubing it is because if my z still represented 2, 2 cubed is 2 times 2 times 2, which is 8. Okay? That's not tripling it. The product of 6 and p plus the product of 3 and y. So product is the same thing as multiplying. So the product of 6 and p, so we're doing 6 and p, we got to multiply them, plus the product of 3 and y. So we have to multiply 3 and y. So there's my expression. Okay, now we're going to talk about the distributive property. So when we distribute things like this, we're just going to send it to both things. So I'm going to have negative 4 times a minus, because we have that minus sign in there, negative 4 and 3. Okay, so negative 4 times a is negative 4a. And then we have 2 minus signs here. 2 minus signs always make a plus sign. Okay, and then we're going to do 4 times 3 is 12. If you don't like writing it that way, I'm going to go ahead and erase this so that I can show you a different way to write it. Okay, you could have also done that negative 4 times a, and when you distributed this, for that negative 3, you could take negative 4 times negative 3 like this. So you'd have negative 4a, 2 negatives, so negative 4 times negative 3 gets you a positive 12. So you still get the same answer. Okay, so we're going to distribute this. So we got 2 times negative x plus 2 times that negative 4. So I got 2 times negative x is negative 2x, and 2 times negative 4 is negative 8. Okay, you could have also written it negative 2x plus negative 8, which that would make it to just a negative 8, because a positive and negative always equals a negative. Okay, so this, we're going to have to use order of operations. Okay, so I have parentheses. Can I take m minus 1? No. They are not the same thing. If that one had an m attached to it, they would be like terms and I could do it. But they don't right now. So we can't do anything in our parentheses. There are no exponents. Okay? Can I multiply anything? Yes. I can send this 2 and multiply it through. So I'm going to have 5 plus 2 times m plus 2 times that negative 1, because I'm distributing it to both of them. So I got 5 plus 2m, and 2 times negative 1 is just negative 2, because I'll have that plus or minus, and it switches to a negative 2. Okay? So now, are there any like terms I can combine? I can combine this 5 and negative 2 because they're like terms. I can't combine that m with anything because there's no other things attached to m. So 5 minus 2, or 5 plus negative 2, is positive 3 because that 5 is bigger. So this is my answer. Okay, I can't add 3 into m because the 3 doesn't have an m attached to it. Okay, so let's write our PEMDAS up here. Okay, so first thing is parentheses. Can I do anything in my parentheses? Those terms don't have j's attached to them, so I can't add them because they're not like terms. Okay, and they're separate, they're still in their parentheses. So my next thing, exponents. Don't have any exponents. Is there anything I can multiply? I can send this 2 all the way through. Okay, so I'm going to have 3 times 2 plus 3 times j. Well, what about here? Because I have parentheses. Okay, that negative is the same thing as a negative 1. There's always a 1 there if you don't see a number. So we have to distribute that negative 1 to everything. So I'm going to have plus negative 1 times 2j, and then plus negative 1 times that 3. I got to distribute that negative 1 to both. So now let's simplify. 3 times 2 is 6. 3 times j is 3j. Negative 1 times 2j is negative 2j. Negative 1 times 3 is negative 3. Okay, now are there any like terms I can combine? Because we always want to simplify it down as far down as it can go. So it looks like I have 2 j's right here. So 3j minus 2j is just j. And then I have the 6 and 3. So 6 minus 3, or 6 plus negative 3, is just 3. So then I got 3 plus j is my final answer. Again, I cannot combine 3 and j because 3 does not have a j attached to it. Okay, is negative 1, 1 a solution to y equals 2x minus 1? Okay, so this is an equation that you could graph it if you wanted to. Okay, so pretend this is my graph and I graph that line. Okay, because it's in y equals mx plus b, so it's something we can graph. I want to see if this point sits on this line. So hopefully, well, 1, negative 1 would be down here. And if that line was true, I don't know if that's true, I just kind of guessed it. But I want to see if this point lies on this line. So what I'm going to do is erase all this. I'm going to plug this point in for my x and y to see if it sits on that line. If it does, it'll be true. Okay, so here, let's just plug it in and see. So my points are always x, y. Okay, so I'm going to plug this in for y and this in for x. So my y is 1 equals 2, my x is negative 1 minus 1. Okay, so I got 1 equals 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. Does 1 equal negative 3? No. Okay, so that point is not a solution because it does not equal what it's supposed to equal. It is not true. So is it a solution? No. It is not a solution.